Hello, I'm Mrs. Gianetto, and I'm going to be teaching us today about transformations and congruence. So I'm going to share my screen. Okay, so we're going to start off with today's lesson right here. So our TEK is 8.10a. Our lesson target is I will understand congruent figures and the different effects of transforming shapes on a coordinate plane. And our essential question is, how do you determine if two figures have the same size and same shape? What are the different transformations of shapes on a coordinate grid? Lastly, our DOL is given 4 problems. I will understand the different effects of transforming shapes on a coordinate plane with at least 3 out of 4 times or with 75% accuracy. So first things first, we're going to go over important vocabulary. Our first word is congruent figures. So congruent is going to be a very essential word for us to know what it means. And congruent means shapes that have the same shape and size, but also angles. So I'm going to go ahead and write angles here. Corresponding sides. Corresponding sides are sides that have the same relative position in similar shapes. So to remind ourselves, I'm going to go ahead and draw 2 triangles. And what makes them similar is that they are the same shape, but of course they're different sizes, as you can see here. And so corresponding sides are sides that are in the same position, right? So I'm going to say this left side and this left side right here. Or I can choose a different one. I can say this bottom side and this bottom side right here, and that's the base. So the next vocabulary word is corresponding angles. So similarly to corresponding sides, they're angles that have the same relative position in similar shapes. So that would be this angle right here and this angle. Or this angle right here. And this angle right here. And we know that there's a relationship between corresponding angles and congruency. So for that first angle that we had right there, let's say that this bottom left angle is 40 degrees. If this one on the right is 40 degrees, we know that this one on the left is also 40 degrees. We can also say the same for the one on the right. If the one on the right is, let's say, 45 degrees, we also know this bottom right angle on the smaller triangle is also 45 degrees. Next is the word orientation. So orientation is talking about the position, which includes the direction a shape is in. So again, the keywords are position and direction. The next vocabulary word is rotation. So rotation is a type of transformation that takes each point in a figure and rotates either clockwise or counterclockwise. So I'll draw what that looks like. So clockwise is the way that a clock works. This is clockwise. Counterclockwise, I'm just going to write CC to stand for counterclockwise, is the opposite of the way a clock works. At a certain number of degrees around a given point. The shape stays the same, but the position on the coordinate plane changes. So this is important. If the shape stays the same, that means it's the same shape, same size. We know that it's congruent. But we know that if the position changes, we know that the orientation changes or the orientation is not maintained. Our next keyword is reflection, a type of transformation that flips a figure across a line of reflection that creates a mirror image of the shape. Each corresponding point is the same distance from the line of reflection. So because we're talking about these shapes on a coordinate grid, so coordinate grid being like this, where we have the x-axis horizontally, the y-axis vertically. Most times in 8th grade math, or the math that we're learning, our x-axis is going to be our line of reflection or our y-axis. Then our next keyword is translation. So translation is a type of transformation that slides the points in a figure the same distance in the same direction. So we know that if it slides across a coordinate plane, that because it's horizontal, it can move horizontal. We know that it can either go up or down, as well as left or right. And if it's going up or down, we know that that's going to be across the y-axis. And if it's going left or right, we know that's going to be across the x-axis. Lastly, we have the word dilation. Dilation is a type of transformation that resizes a figure, making the shape bigger or smaller. So usually the shape gets bigger or smaller. Dilation can actually make the shape stay the same if the scale, which I'm going to include that as a bonus vocabulary word, we use the letter K to represent that, is equal to 1. And we'll talk more about this when we go into each of the 4 transformations more in depth. So here's a visual of the 4 transformations. So an easy way to remember that translation is a slide is that we have SL in translation is the SL in the middle of translation and slide. Next, we have the FL in flip is the FL in the middle of reflection. So in rotation, you can see that there's 2 T's and there's a T in the word turn. So rotation is a turn. And for dilation, that's just a resizing, right? We talked about getting bigger or smaller. Okay, specifically with rotation, when you rotate a shape, the sum of the angle measures does not change. So what that means is that triangles, when you add them up, the interior angles, the inside angles all have to equal 180 degrees. Even when the triangle is rotated, that doesn't change. It's still 180 degrees after it's rotated. So as a reminder, we can rotate clockwise or counterclockwise. And in terms of the degrees that it can rotate, as you can see in our example, we have 90 degrees, we have 180 degrees, and we have 270 degrees. If you can figure out the relationship between them, it's that we're adding 90 to each one. So what wasn't included, of course, was 0 degrees and 360 degrees. We know that 0 degrees is the original position, 360 is a full turn that would return it to look exactly like that beginning position at 0 degrees. And if we look at the coordinates right here, each of these start with x comma y. But you can see that once it's rotated, that sometimes the y comes first and then the x comes second. So that's what happens in a rotation. That's the important thing to know, is that for most, the x and the y are flipped. The special exception is for a rotation of 180 degrees, where both the x and the y become negative, or the opposite sign. So if it started as a negative number, let's say x was -5, y was -10, then it would actually become a +5, +10 in that case. So we know that in a rotation, the shape is congruent. That means that it does not change shape, size, or angle. The side lengths stay the same. The rotated shape usually changes its orientation, but as you can see from this 3rd bullet point, that it can maintain its orientation if it's rotated 360 degrees, right? So that's the original position. So the area of the rotated shape is the same as the area of the original shape. Means is if we found up how much space that this triangle took up, we would know that it's the same amount of space that this triangle takes up, the inside of the triangle. Lastly, we know that the angle measures of the corresponding angles are congruent. We talked about that earlier, that angle B right here would be congruent to B prime right here. So the angle measures would be the same because they're corresponding. Okay, for reflection, we talked about that because most of these shapes are going to be transformed on a coordinate grid, that most times it's going to be reflected across the x-axis or the y-axis, as you can see in the visual. So again, the sum of the angle measures does not change. The reflected shape does stay congruent. So again, the shape, size, angles do not change. The side lengths do not change. The area does not change, right? The area is the same. The one thing that does change, though, is the orientation or the position. The position does change. So the way that we can see that is individual. So let's start with the left side. So we can see that up here, A is on the top left, but when it's reflected over the x-axis, A prime becomes on the bottom left. And of course, B stays on the right, but C goes from being on the bottom left to the top left. And then if we look at direction over the y-axis. So A goes from being on the top left to the top right. C goes from being on the left to the bottom right, and B goes from being on the right side to the left side. Lastly, with translation. So translation is a slide, right? So we're just sliding it across the x-axis or the y-axis. And so if you guys remember, the 4 directions that we can move are up, down, left, and right. And if we're going up or down, that's going to be affecting the y-axis. If we're going left to right, that's going to be affecting the x-axis. Over here, we see our x comma y to x plus 5, y plus 2. So we know that if it's affecting the x-axis, we're either moving left or right. And because we're adding 5, we know that we're going to be moving to the right side, as you can see right here, because we want the numbers to get bigger. Then if we have the y plus 2, we know that we're either going up or down. But because we're adding 2, we know that we're going up. Because again, we want the numbers to get bigger. We can also subtract, which of course would make it go left or down. So again, when you're going up, you're adding to the y-axis. When you're going to the right, you're adding to the x-axis. So the sum of the angle measures does not change. The translated shape is congruent. So same shape, size, angle. The side lengths stay the same. The translated shape does maintain its orientation. The orientation stays the same. So the way that I can show that is if I label this blue triangle, let's say A, B, C, D. Even when it's translated, this becomes A prime, B prime, C prime, D prime. So the prime is what we call that little apostrophe next to the letter. And that's how we know that's the new shape, right? The old shape, the original shape won't have the letters. So this shape has been translated down and to the right, but we can see that the positions of the letters are still in the same corners, in the same places. Okay, so we know that the area of the translated shape is the same because if we wanted to count the number of boxes, we can see that there would be 6 boxes, or this blue triangle with 6 square units. This red triangle is also 6 square units. And we know that the angle measures of the corresponding angles are congruent. The last one is dilation. So again, we know that the old shape does not have the prime, right? It just has the letters A, B, C, and that the new shape is the one that has the little apostrophe or what we call prime. So in this case, the shape got bigger. If we look at this rule right here, we can see x comma y, so 4x comma 4y. We see that there's that in front. Remember what I mentioned earlier. If the scale factor is equal to 1, shape but if this scale factor is greater, so let's imagine what would happen to. So I'm going to pick 2 numbers. I'll pick 1 and 2, right? So our x is 1, our y is 2. Let's use this rule to find our new coordinates. So if we have 4x, that means 4 times x. Anytime in math we have a number and a letter, we're multiplying. So we have 4 times 1 is 1. Then we have 4y, so that's 4 times y. 4 times 2 is 8. So we're going from a coordinate 1, 2 to the coordinate 4, 8. So of course we can see that the shape got bigger. So we know that when k is greater than 1, the shape gets bigger. Use a fraction as an example because fractions are always less than 1. So let's do half. So our rule will be half x comma half y. So using that same original 1, 2, half times 1, or 1 divided by 2, or 0.5. Then we have half times 2, or 2 divided by 2 is. So again, we could have written this as a fraction, or we can have it as a decimal. Either works. We have half comma 1 or 0.5 comma 1. And obviously that's smaller than 1 comma 2. So we know that when the scale or the number in front of the X and Y is less than 1, the shape gets smaller. So again, the sum of the angle measures does not change, but because the size changes, the shape is not congruent. The congruency, it does not maintain its congruency. So the dilated shape does maintain its orientation though, because as you can see, A here in this pinkish small triangle is on the bottom left. In the bigger green triangle, it's still on the bottom left. B in the pink triangle for the original triangle is on the top. B prime is also on the top. And the same with C and C prime. They're in the same position or direction. So now with our first redo, which transformation does not preserve orientation? So first we have to remind ourselves what orientation means. Orientation means direction, position. So right away, I remember that translation, sliding it, maintains orientation because we're not changing the shape, size, or angles. Dilation, which we just talked about, also maintains orientation because we're just sliding it. The direction or the position of the letters or the vertices of the shape, the corners of the shape do not change. So now we're left with rotation and reflection. And this is a tricky one because with rotation, I remember that it says it can maintain its orientation, but that's only if it's rotated 360 degrees. So I guess that was the trick answer. So our only correct answer is going to be reflection. So reflection does not preserve orientation. So in this case, for our success criteria, I did determine which of the 4 transformations maintain congruence because I first crossed that out since this one was a not preserving orientation. So we know that rotation maintains congruence. Translation maintains congruence. Reflection maintains congruence, and it's dilation that does not. I can determine the effects of each of the 4 transformations on a figure and its position on a coordinate plane. So I did just that. And I can understand a transformation rule to decide its effect on a figure's angles and side lengths. So for this problem, we didn't necessarily need a translation rule. Okay, we have the next redo. This one is talking about an image has a different orientation and size than the original figure. Which 2 transformations could have been applied to the original figure to create the image? So if we're talking about changing orientation, again, we know that's direction or position. We already narrowed it down to either rotation or reflection. In the last problem, our answer was reflection. And then of course, with changing of size, we know that the only one that changes size is dilation. So I'm going to cross out any one that does not have dilation. So that leaves us with B and C. C says translation and dilation. So I know that can't be correct. So the answer is going to be B, reflection and dilation. So the rest of the lesson is the UDO and independent practices. Thank you so much for following along and see you in the next lesson.